Okay, we're going to test the series for convergence or divergence. So what test do you want to use? What I would use is the ratio test. Why the ratio test? Because we have an n factorial, first of all. Whenever you have an n factorial, you tend to use the ratio test. And we have something being taken to a power, which gives us even more reason to do a ratio test. So with the ratio test, it's different from the limit comparison test. We also have division. People get this confused. So limit as n approaches infinity. With this one, we have a sub n plus 1 over a sub n. And we take the absolute value. With this one, we're looking to have something which is less than 1. If whatever we get when we take the limit as n approaches infinity ends up being less than 1, then this converges. It converges. So that's what we're looking for. Something which is less than 1, hopefully, if we like convergence, right? So a sub n plus 1, what is that? And obviously, since we're dividing by a sub n, that's going to be the reciprocal. So over here, we're going to have the reciprocal of this, and over here, we're going to plug in n plus 1 for all the terms where we see an n. So this is this, e to the n plus 1, and that's squared because we had n squared, and now we multiply by the reciprocal, which is e to the n squared over n factorial. Now we can start to cancel stuff out. So right here we have n factorial times n plus 1. N factorial times n plus 1, this is something that I've explained in a bunch of other videos if you don't get that. But yeah, n factorial cancels out. This, we can expand that, we can expand the exponent. So this is going to be basic algebra, n squared plus 2n plus 1. And now we can cancel out the e to the n squared. If you don't get that, that's because of the properties of exponents. So you have e to the n squared times e to the 2n plus 1. Or equivalently, you have e to the n squared times e to the 2n times e to the 1, which is just e, right? These are all equivalent things. You could multiply in this way when you have addition in the exponent. So that means that we can cancel the n squared with this form. So we're going to cancel out this one and just be left with this. So e to the 2n plus 1, e to the 2n plus 1, and this one went away. That one went away. So got rid of this, got rid of this, and that's what we're left with. We could get rid of the absolute value signs because this is always going to be positive. We take the limit as n approaches infinity, and we can already see at this point that we have an infinity which is greater in the denominator because this one's an exponent at infinity, which is a greater, more powerful infinity than this infinity in the numerator. That means that this is going to go to 0 because you have a more powerful denominator, a more powerful infinity in the denominator. So we take a limit as n approaches infinity, and this is 0, which is certainly less than 1, which is what we were looking for with the ratio test. So if it's less than 1, it converges. So this does converge.